Hello and welcome to our first lesson in our unit on absolute values and radicals. And we'll start with the definition of absolute value. So the absolute value of a number gives its magnitude or its distance from 0 on the number line. So if we have a number line here, 0 there, and we've got the absolute value of 4, obviously from 0 to 4 on the number line is 4 units long. Also, if I do the absolute value of -5, the distance from -5 to 0 is 5. Essentially, what the absolute value symbol does is it's like brackets that anything that comes out of those brackets is positive. So for our next example, we have 4 minus 7 is the absolute value of -3 is 3. Okay, so absolute value of 12 is 12. Absolute value of -4 is 4. Absolute value of 12 minus 3 is the absolute value of 9, which is just 9. And this time we have to do some brackets inside the brackets first. We end up with the absolute value of -2 times 2, which is the absolute value of -4, which is just 4. Okay, and the absolute value can also be used to determine the distance between two numbers on a number line. So the absolute value of -5.9 minus -10.2 equals the absolute value of 4.3, which is 4.3. And on the number line, I have 0 over here, -5.9, -10.2, and between those two we're going to have 4.3. Okay, this one we've got 2 3/4 minus -3.5, and that equals the absolute value of 2 3/4 plus 3 2/4 to get a common denominator, which gives us the absolute value of 6 1/4, which is 6 1/4. There's our number line. This case we're going to have 0 in the middle, 2 3/4 over here, and -3.5 over here. So that's going to be 3.5. That's going to be 2 3/4. If we add those two together, we'll end up with 6 1/4. Okay, and now we're going to look into the relationship between absolute value and square roots. So notice that 5 squared equals 25 and -5 squared also equals 25. So the square root of 25 could be either 5 or -5. Because this isn't very convenient to talk about as a square root, we always talk about the principal square root, and that's always the positive value. So if I want the square root of the square root of 25, I'm always going to get 5. Okay, let's have a look at 3 here. So how are these two things related? Well, first let's figure out what they equal. -3 squared is going to be 9, so I'll have the square root of 9 equals 3. And the absolute value of -3 is also 3. Well, they're the same. They're both 3. Okay, does the square root of x squared equal x for all values of x? Well, let's try it for x equals 3. So the square root of 3 squared, does that equal 3? 3 squared is 9. Square root of 9 equals 3 because we always choose the principal square root. It's going to be positive, so yeah, that's true. Okay, let's try it for -3. Does the square root of -3 squared equal -3? -3 squared is 9. Oops. So the square root of 9 equals -3. Because we always choose the principal square root, we're going to get 3 equals -3, which isn't true. So does this always equal the same for all values of x? No. The left side is always going to be positive. So the square root of x squared, oops, that's a terrible squared, is going to equal the absolute value of x. So it's basically going to be the same number, but always positive. Okay, question 5. Let's use that knowledge. So that's going to be the same as the absolute value of 2.554, which is just 2.554. Next one, this is going to be the absolute value of negative 7 4/5 plus 3, which equals the absolute value of negative 4 4/5 equals 4 4/5. Okay, question 6. For these slightly more complicated expressions with absolute value in it, just remember they act the same as brackets, so we need to do them first with our order of operations. So we'll start out with negative 26 plus 14 is the absolute value of negative 12, minus 2 times the absolute value of 10 minus 4 is 6. So absolute value of negative 12 is 12, minus 2 times the absolute value of 6 is just 6. So we get 12 minus 12 equals 0. Okay, for b, we're just going to have to put in 2 for x. So we get the absolute value of negative 2 times 2 squared minus 3 times 2 minus 4. And again, we need to work inside the brackets first. That was supposed to be an equal sign. So 2 squared is 4, times negative 2 is negative 8, minus 6, minus 4. So we get the absolute value of negative 18 equals 18. That's it. So yeah, absolute value symbols are basically like brackets, except for anything that comes out of them is positive. And the other thing you need to remember is that this square root of x squared equals the absolute value of x, because everything that comes out of this side is positive, so to make it equal, everything that comes out of that side also has to be positive. Okay, seeing as there isn't much to that absolute value lesson, we're going to do some review of grade 10 radicals now. The stuff at the top of your page there is basically just telling us that 2 root 7 can be rewritten as square root of 4 times the square root of 7, which is the same as the square root of 28. Okay, this guy is the same as the square root of 49 times the square root of 2, which is square root of 98. 5 is the same as the square root of 25 times the square root of 10, gives us the square root of 250. 2 is the same as the cubed root of 8, because 2 times itself 3 times is going to be 8. That's messy. And that's times the cubed root of 6, gives us the cubed root of 48. 3 is the same as the cubed root of 27 times the cubed root. It's a weird looking thing. Times the cubed root of 4 is the cubed root of 108. And 3 is the same as the 4th root of 81. And that's times the 4th root of 9. Gives us the 4th root of 729. Okay, 8, we're basically doing the opposite. If you can, I would recommend trying to see this and just go, well, 18 is a multiple of 9. So that's root 9 times root 2. And the square root of 9 is 3. So that's 3 root 2. If you can't do that, then what you want to do is factor the number 18. So break it down into as many things multiplied together as possible. The way I do that is I divide it by 2, I get 9. Can't divide by 2, so I divide it by 3, I get 3. Divided by 3, I get 1. So 18 is the same as 2 times 3 times 3, or 3 squared. So I can pull out the 3 squared, and I get 3 root 2, the same as I did up here. Okay, again, square root of 147 is the square root of 49 times the square root of 3, or 7 root 3. Or you can break it down. Can't divide by 2, I can divide by 3, I get 49. Oops. Just that I can't divide by 2. Divide by 3, I get 49. Can't divide by 4, 5, 6. I can divide by 7. That gives me 7. And 7 gives me 1. So 3 times 7 times 7. Because I have 2 7s, that's 7 squared, which I can pull out as 1 7 out of the root sign, equals 7 root 3. Root 27 is 3 times itself. 3 times. 2 of those are 3 squared, so I get 3 root 3. 1008. Alright. Let's do this guy the old-fashioned way because he's pretty ugly. So I can divide that by 2. I get 504. Divided by 2, I get 252. Divided by 2, I get 126. Divided by 2, I get 63. Can't divide by 2 anymore. I can divide by 3. Oof. So I divide by 3, I get 21. I divide that by 3, I get 7. And then the only thing I can divide by is 7. So 1008 is the same as 2 times 2 times 2 times 2 times 3 times 3 times 7. So I have 2 2's there, 2 2's there, and 2 3's there. So on the outside I'll have 2 times 2 times 3, and I'm left with root 7 on the inside, so that's 12 root 7. Okay, cubed root of 27, as we showed up here, 27 is just 3 times itself, 3 times, so cubed root of 27 is just 3, and 16. 16 is 2 times itself 4 times. Because this is a cubed root, I need a cube to take something out, so I end up with 2 cubed root 2. Alrighty, so same as with multiplying, I can break this into 2 things with dividing. So I get cubed root of negative 40 over the cubed root of 81. Let's have a look at 40 over here. So I can divide that by 2, I get 20. Divided by 2, I get 10. Divided by 2, I get 5. Divided by 5, I get 1. So 40 is the same as 2 times 2 times 2 times 5. So on the top I'll get negative 2 cubed root 5. And then 81, I know is 3 times itself 4 times. Because it's 9 times 9, or 3 times itself 4 times. So again, I need to use 3 of those to pull a 3 out, so that's going to be over 3 cubed root 3. And they may want that as negative 2/3 over the cubed root of 5 over 3. Okay, B, they ask us for an entire radical. Notice I'm not going to be able to bring the negative in, because I can't take the 4th root of, of a negative, so I'm just going to leave the negative on the outside. And I'm going to write 2 as 2 over 1, which as a 4th root is going to be the 4th root of 16 over the 4th root of 1 times the 4th root of 3 all over the 4th root of 4. So I can put all of that together under one huge root. I get 16 times 3 over 1 times 4. 16 over 4 is the same as 4 over 1. So that gives me negative 4th root of 12. Okay, notice all of this stuff is from grade 10. You'll be expected to know this stuff cold to be able to do this unit. So if you're not very good at it, I recommend going on Khan Academy or something and getting real good at this real fast.